In the project entitled Evaluating the ATV Stability and Rollover Protection in Agricultural Environments Using Finite Element Modeling, a commonly used ATV in agricultural settings was selected. Since the mechanisms of the front and rear suspension systems are important components of the stability control system, the dimensions of the components were measured carefully to obtain an accurate model. Accordingly, the front and rear suspension system, which was a double wishbone, was modeled with all the components. In addition, front and rear racks are used to carry attachments on the ATV, while the front bumper connects the front rack to the main chassis. Furthermore, the small chassis serves as the supporting structure for the rear suspension system, and the anti-roll bar reduces body roll and improves lateral stability. Moreover, the handlebar is used to control the steering direction of the ATV. A 360-degree view of all the components used in the CAD model of the ATV can be observed. The shock absorbers were modeled in detail during the CAD development stage. However, in the final finite element model of the ATV, equivalent spring and damper definitions were used to represent their mechanical behavior. To reduce the number of elements in the FE model and improve computational efficiency, the ATV tires were simplified as treadless shell components. In addition, a rescue Randy mannequin with a weight of 75 kilograms and a height of 165 centimeters was used. The developed dummy model was attached to the ATV at 5 key points, including the handlebars, footrests, and the seat reference point, to simulate realistic rider interaction. Furthermore, various attachments, including solid and liquid-based attachments mounted on the front and rear racks and a trailer connected to the towing bar, were used. Consequently, a multi-body finite element model of the ATV, equipped with all attachments, was developed in Abacus/CAE 2020. The model was used to perform several static and dynamic tests, including the lateral rollover tilt table test, in which the ATV is released on a tilt table at an angle 5 degrees greater than the maximum stability angle of the ATV in the lateral, forward, and rearward directions. In this test, the head injury criterion or HIC, the final position of the rider relative to the ATV, and the pressure applied to the rider's chest are evaluated, since chest compression is a common cause of injury and death in agricultural ATV accidents. Rollovers are significantly more common among farm workers, accounting for approximately 85% of incidents, compared to 55% in recreational settings. In addition, farm workers are more likely to become pinned beneath the ATV during an accident and to suffer fatal compression asphyxia compared to recreational riders. Another test is the tilt table ratio or TTR test, which provides the opportunity to measure the static stability angle of the baseline ATV as well as the ATV equipped with different attachment configurations. In addition, the bump obstacle perturbation test evaluates the dynamic stability of the ATV while passing over bumps of varying heights under different tire inflation pressures and with both solid and liquid-based attachments. Another important evaluation is the lateral transient response, or J-turn test, which measures the time response of the ATV under different tire inflation pressures and attachment configurations. In this test, the ATV travels at 20 km per hour, after which the rider applies a sudden steering input to generate a lateral acceleration of 0.4 g. The yaw rate of the ATV is measured using an inertial measurement unit or IMU, and the corresponding response time is determined. Because this test is both time-consuming and dangerous, the finite element model of the ATV provides an effective alternative for conducting the analysis. Finally, the side upset test simulates rollover conditions in a dynamic mode and evaluates the dangers that may threaten the rider during such events. This test is part of a more comprehensive assessment of crush protection devices and their effectiveness in reducing the risks that can cause injury or death to ATV riders. All of these tests were specifically designed and adapted for ATVs because these vehicles are inherently less stable than conventional four-wheeled vehicles due to their narrow wheelbases and high centers of gravity. These characteristics make ATVs particularly susceptible to rollovers, especially on steep or uneven agricultural terrain. Ultimately, the results of this study will provide recommendations aimed at improving the safety of agricultural ATV operations and ensuring safer working conditions for ATV users.